Hey guys, it's me again, Captain Corey, here to help you with some sixth grade science. Last week we talked about the properties of water, and I noticed that some of you all had difficulties reaching the science journal. So I'm going to share my screen with you and show you how to get access to the science journal. All right, so first what you're going to do is you're going to open up your web browser, and then you're going to go to rvaschools.net. Once you get to this page, you're going to scroll down to RPS at home and click on that. And that link should lead you to the RPS Tech page. Then you're going to click on middle school and sixth grade. Once you do that, you're going to come down and click on April 13th because that's the week that we're currently on. Since it's not available for demonstrations purposes, I'm going to show you using the 6th. So once that page uploads, then you're just going to come on down and click on Science Journal. And there should be a link and you can click on that link. Once you get to that link, you have a couple of options. The first option is you can go to File and click Make a Copy. Once you click Make a Copy, you can change the name to whatever you want. You can keep the name and put like your name right there to make sure that you know that the document is yours, and it'll save to your Google Drive. If you don't have a Google Drive, what you could do is you could go over to download and then you can click Microsoft Word, right? So once you click Microsoft Word, then it will download and then you go to your downloads and then you will open up the science notebook journal. So I'm waiting for it to download. Once it downloads, it's gonna look kind of like this, and the formatting might be a little bit off. So what I suggest that you do is what I did was I deleted this atom and then I just press enter, and then my page 2 look like that. So that's our See, Think, and Wonder page. And then down here was my brain pop activity. And then I press enter again to make sure that my property of water notes were on the same page, and then go down. And then there was an at-home experiment last week that you had an option to do. And then that got everything on the right page, and we're set and good to go. All right, so this week we are going to talk about the role of thermal energy and what that plays in phase changes. Since today is Monday, we will engage and explore. So first we will watch 2 videos. While we are watching these videos, please go into your science journals that we just copied and fill out the Notice and Wonder sheet on the first page. If you want an opportunity to get a shout out on next week's video, then you can log on to Nearpod and use the code that's provided in the screen above and submit your answers. So if you see something really cool that blows your mind and you really want to share it, you want an opportunity at a shout out, just log on to Nearpod and put your answers in there. Be sure that you put your name and your school so that you can get a proper shout out and proper recognition for your awesome answers. If at any time you need to pause or rewind the video and write down your observations, that's perfectly fine. The links to everything that I'm about to show you are also on the RPS Tech website. All right, so here goes our first video. Wow, that was really interesting, right? So now we're going to look at our next video, and don't forget to write 3 things that you see, 3 things that you think, and 3 things that you wonder, and submit it if you want a shout out. I can't wait to read everything that you guys observed. All right, so now we're going to explore more about thermal energy's role in phase change, and we're going to watch a quick brain pop. After the video shows, we will go into our science journals and fill in a flow chart. The flow chart will be asking you to describe the process of water changing from a solid to a liquid to a gas. So these are the things that we should be looking for in the video. So I'm going to repeat that. You're going to do a flow chart, and it's going to describe the process from a solid to a liquid to a gas. All right, let's check out this video. All right, here we go.
Dear Tim and Moby, what happens to matter when it changes states? Sincerely, Robert. I'd be happy to show you, Robert, but the last time we talked about the different states of matter, Moby was an absolute menace. You promise? No squirting me with water guns or dropping ice cubes down my pants. Okay then. Matter is anything that has mass and takes up space. And the basic states of matter are solid, liquid, and gas. Water is a good example of matter because its 3 states are all pretty common. Its solid form is ice, its liquid form is water, and its gaseous form is steam or water vapor. Like all matter, water changes states due to changes in temperature and pressure. But its chemical properties remain the same. A molecule of ice is the same as a molecule of water. State change is a purely physical change. Hey, I said no funny stuff. Give me the squirt gun. Molecules of ice are bonded tightly to one another in a structure called a crystal lattice. These molecules all contain energy, and that energy makes them vibrate. Wait a minute, where's the ice? Are you sure? You were going to put this in my pants, weren't you? When you heat the ice, you give these molecules more energy. They begin vibrating faster and faster. Finally, they break free of their bonds. When all the bonds have broken, the water molecules are free to flow past one another. And the ice is now liquid water. That's called melting. And the temperature at which a solid substance melts into a liquid is called its melting point. Every element or compound has its own unique melting point. The melting point of water is 0 degrees Celsius or 32 degrees Fahrenheit. Check this out. If you stick a thermometer in the ice as it melts, you'll notice something interesting. The ice starts out at around minus 10 degrees, and as it's heated, the temperature climbs to 0 degrees Celsius. But then, it just stays at 0, even though the flame on the stove is on full blast. The temperature doesn't start rising again until all the ice melts. As long as there's some ice left, all that extra energy goes into breaking the bonds that hold the crystal lattice together. This extra energy is called the heat of fusion. Well, the process of turning a liquid into a gas is, hey, what's with the hose? The one that you're hiding behind your back. You better take it back outside before Mom flips out. Anyway, gas molecules have more energy than liquid molecules. Liquid molecules are attracted to one another and tend to clump together. But gas molecules bounce around randomly. To turn a liquid into a gas, you've got to add enough energy to overcome the forces of attraction between those molecules. That energy is called the heat of vaporization. When we add heat to water, its temperature rises until it hits the boiling point, the point where it starts turning into a gas. For water, that's 100 degrees Celsius or 212 degrees Fahrenheit. The temperature stays constant until all the water turns to vapor. Sometimes substances change directly from a solid into a gas. That's called sublimation. It doesn't usually happen with water, but you can see it with something called dry ice. Dry ice is solid carbon dioxide. At room temperature, it turns directly into a cloudy white gas. It doesn't go through its liquid state at all. Sometimes dry ice is used to make artificial smoke at places like concerts or Halloween haunted houses. You have dry ice? Cool, can I see it? How did I know that was going to happen?
Alright, so now that the video is over, be sure to go to your science journal and fill out the Brain Pop activity sheet. If you need to see the video again, you can rewind and pause as many times as you need to. Until next time, this has been Science with Captain Corey.